Hello students. So this lab is lab 1 is going to be kind of a review, but also some of the stuff we learned in lecture. You probably already learned this from last mechanical ventilation. We're going to be talking about airway resistance. We're going to talk about compliance, and we also want to be able to calculate that. I know the ventilators all spit out a compliance and airway resistance and all that. Well, you need to actually be able to do it on your own. So you have the formulas. We've learned that. Again, we reviewed this with this lecture. But so I'm going to introduce you to the PneumoView 3 simulator, lung simulator from Michigan Instruments. And then we're going to hook it up on the 980. And so you guys can do this. You guys will be working in a group of 4 on each ventilator, and we'll see how much time we'll give you, maybe about an hour. You guys can go through that assignment that you have for lab 1, okay? So let me show you the PneumoView. So this is the lung simulator, okay? I already attached the adapter for the ventilator circuit and the pressure line, so we can read pressure on the manometer here. Though you might not be looking too much at that necessarily, because you'll be looking at the pressure on the 980. Anyhow, make sure that the this plate is lifted up all the way, allowing the lung to freely move up and down. Okay, and real quick review. There's a couple parts on this that we're going to talk about. That one adjusts the compliance. This is the spring that adjusts compliance as we slide it up to the top of the lung. There, it's going to create more compliance. So we're going to see decreased compliance. So right now it is this is the minimum location. You don't want to have it set lower than that. So it's 0.10 is where you will always start this lung simulator, and then as we decrease compliance, we'll move it up, and you'll see what it looks like on the waveform. These adapters here are resistors. These are going to show airway resistance, and we will put these adapters on the adapter there on the PneumoView, and then here we'll connect the ventilator circuit. But right now we're going to just do it with no resistance, no compliance issues. So I'm going to turn this on up here, and we'll just same patient. I already have some settings on there. There's we're on volume control, ACVC, okay, flow trigger. We have total volume set at 480, frequency of 10, flow, Vmax flow liters per minute is 50 liters per minute. It's on a waveform as a ramp, which is the most natural way for breathing, and we have sensitivity set at flow trigger sensitivity at 3 liters per minute, 100% FiO2, which we can adjust that if we need to, but anyways, in a PEEP of 5. Okay, so I'm going to go ahead and start, and it's going to want me to connect, and I'm going to connect the circuit, and it connected, and the lung is moving, and it's started displaying. Okay, so remember, you need to go on whichever ventilator. We're going to be working with the 980 with the PneumoView for lab 1, and you should be able to know how to access the flow. What's your manual? Okay, the waveforms or the loops right there, and we have it set on the layout to show all the scalars, the 3 scalars, and the two loops. Layout 4, which we have there. So now what you're going to be doing is once you have it all set up and you set the alarms according to the alarm limit sheet on the ventilators, set that all up, and then what we're going to do is we're going to be looking at the waveform, the loops. We're looking at the volume pressure loop up here. This is where we can see compliance changes and resistance changes. Okay, And remember how to do a compliance. We're going to do a compliance by doing an inspiratory pause. I'll click it, and it's going to create that pause, which it did immediately. And right now it will display the plateau pressure, 9.1. And of course, it's going to spit out your compliance right there. Okay, 95. So we will accept that. Okay, we accepted that. And so now what you're going to do, let's go back to close it. Go back to our waveforms, and we're going to decrease compliance. And doing that, we're going to raise this, move this spring a little bit higher. So I'm going to go up to 0.3 on here. I'm going to wait till the lung is an exhalation phase, and then I'll move it. Got to wiggle it around a little bit. Okay, so 0.3. Okay, so now let's go back and look at our loops. Okay, so specifically we're looking at the volume pressure loop. And if you remember what that looked like before, it was kind of straight up. And right now it's kind of beginning to lean now towards the pressure pressure line on the bottom. Okay, so we're going to do another compliance, and we're going to press inspiratory pause. It's going to generate the maneuver, which it did. And remember the last one was 9.1? Yep, so it's listed there. Oh, and now we can see that compliance has changed. Compliance down to 30 from 95, and indicating that we have decreased lung compliance. We have a plateau pressure that has increased. And if you actually look at the PIP, which we didn't look at here, but you need to look at it, the PIP probably hasn't changed much. It says 18 up there, top left. It probably hasn't changed much from when we had no compliance put into it. But you can see plateau pressures have come up. So let's close this. And I'm going to come back here. We're going to add more compliance. We're going to go up to the 0.15, which is right up there. Kind of stiff, not as stiff as the 0.01, but let's move this up. Let me see if I can do it with one hand. You got to wiggle it around. Okay, there we go. And I'm up to the 0.15. And it might create some increased pressures on our okay. So we look at it, we can see pressures have gone up a little bit. It's gone up 31 now. And of course, we're looking at the loop. Remember what the loop looked like before? Now we've added even more, decreased the compliance even more. And now that loop is beginning to getting closer to the pressure line. So let's do a compliance check. Another inspiratory pause. Let's see if it does it with stiff lung like that. Yep, all right, it did it. So we didn't save that last one, which I forgot what it was, but I think it was compliance was 33 or something. I don't know now. But anyhow, so what you're going to do is you're going to look that again. I should have accepted it, which I'll accept this one. But you can see now that the plateau pressure has gone up significantly, 25. And so we're nearing that 30 mark. We need to be plateau pressures need to be below 30. So anyhow, now we have increased lung compliance. We can see the static compliance there. You should do the formula so you can make sure you know how to do that. Now let's look at the waveform again. I'm going to close this, and yeah, it's still there. I'm going to see if I can go up a little higher on this. Let's go up a little higher to the maximum. I have a feeling it might alarm on us, but let's go up. Let's go right there. Yep, there we go. Yeah, it's alarming and everything. Let's silence. Let's just silence it for now, but you can see what's going on. And it's auto cycling because it's on flow setting. and it's picking up a little flow. But you can see the volume, volume pressure loop has really gotten down and is almost is high pressure limiting already at 40. But let's try to do an inspiratory hold if it does that. I'm not sure if it'll do it. Let's see, maneuver canceled, criteria not met. So we it's not going to be able to get that done. Let's try one more time. Let's see what happens. Yeah, it's not going to do it. Let me adjust the alarms a little bit if we can. Let me adjust the high pressure. See what it does. Accept. Oh, okay. All right. It might let us do it now. There we go. Had to adjust that alarm limit. But you can see right now that I'm going to accept this. So you can see how compliance has steadily increased as we created decreased lung compliance. So plateau pressure now at 30. Okay. And of course the peak pressures have gone up because his lungs are stiffer. So I want you to observe that, be able to look and see how as we increase or decrease lung compliance that plateau pressures are rising. Okay. So what we're going to do now is we're going to look at airway resistance. I'm going to reset everything on the lung and I'll be right back. Okay, so I'm back. I'm going to go ahead and put some resistors on here, but let's first look at the waveform. Again, with airway resistance, looking at the volume pressure curve, we're going to begin to see that loop begin to get fatter. Okay, that indicates airway resistance. We won't see plateau pressures changing, okay, necessarily, which we'll look at that. Remember, we did a plateau pressure before. Let's do it right now so we can get a baseline. Okay, so it's generating plateau pressure, should be 9.1. Okay, we'll accept it. 9.1, it's where we are. Let's close it. And there's the waveform. I'm going to add a resistor. We have a couple resistors. One's 20, one's 50. That's all we want to do. There are some other ones that are higher, but I think these are enough to show what we're going to do. I'm going to go ahead and disconnect this. The ventilator will alarm. I'm going to add the resistor, 20. Okay. Try not to push too hard on these things or push in because it could crack the 15 millimeter adapter. But anyway, so we're good. Let's look at our loop. Oh, and there we go. We can see that the loop has changed from it used to be straight up, and now we can see the inspiratory limb is a lot fatter, indicating that's the widening of that loop. Indicates resistance, increased airway resistance. So let's go back to do a compliance. We can do an inspiratory hold again. Does compliance really change? And here it goes. Let's try it. So no, we have no change in compliance. In fact, it's about the same. 92 static compliance and 9.1 plateau pressures. So no changes there, but you need to observe that loop. The loop indicates increased airway resistance. Remember, increased airway resistance could be what, maybe they need a bronchodilator, maybe they need airway clearance, maybe they need to drain the tubing or whatever. This one doesn't look like there's water in the tubing, but that's some of the things that you would want to help to reduce airway resistance. I'm going to add the other resistor on here, and I'll be right back. Okay, I'm back. So I put the number 50 resistor on here, and let's go look at a few things. Let's look at the loop again. Boom. You can see that loop has gotten super fat, really big. The inspiratory limb is really big. The expiratory limb is also a little bit fatter, but there's more air inspiratory resistance. And let's go back to look at the compliance. Has that changed? And most likely has not. So created the compliance. Let's see what it says. Not much difference. So we can see here, I'm going to accept that. So now we can see that the with the one normal plateau pressure was 9.1, and with the increased resistance that we put in with the first one, number 20, it didn't change. And now that we added even more resistance, doubled it, the plateau pressures have not changed. But I'm sure the pips have changed. From 37 used to be I think 18. I'm going to take this resistor off here, the 50, and let's see what. Hang on. Silence. Okay, let's go back. I just put back to standard resistance. Close. So now let's look at, and remember pressure? Pressure increased when we added resistance. It was at 31 with that 50, number 50 resistor on there. So that changed, pressure changed. So that's what I want you guys to do in lab 1, is to look at how compliance and airway resistance changes, and how they look like on the ventilator, looking at the loops, doing the measurements, doing the inspiratory hold, and to look at compliance and checking plateau pressures and peak inspiratory pressures. Okay? All right, great. Well, the other lung simulator that we have is the Ingemar Medical Quick Lung Breather. This is designed to create decreased compliance, and the way we do that is that we hook these rings, these springs, underneath. Let's see if we can do that. Under the plate here, like that. Okay, and then that would be some decreased compliance by doing that, allowing this lung to not expand well, creating a stiff lung. And then we can also add another spring on this side. So now it's a little bit stiffer. I'll tell you right now, if you add this big spring on there, you're going to have problems trying to read or even try to get a plateau pressure because it's too stiff. I would recommend just doing these 2 springs on the outside, and you will see the difference. Okay, so I'm going to go set up the servo I, and if you remember, after plugging everything in, you have to turn it on back here. Behind this, there's a toggle switch, which I just turned it, and then it will begin to display on your screen. Oh, I didn't turn it on. So here we go. I just turned it on, and it's coming. Okay, so it is up. It wants to do a pre-start. We're not going to do a pre-start. We'll say no. Little touchy there. You can use the back of your fingernail to tap it. Do you want to delete patient, trend, data log? Let's do that. Okay, and it's pretty much set, ready to start ventilation. And we can see our mode. We start on volume control. And also remember, remove that T-pause. We don't need to have a T-pause in there every breath, so we're going to turn that off. Okay, you know how to do that. This is our settings: tidal volume 500, respiratory rate of 15, got a PEEP of 5, 40%. We're at a flow trigger. You can actually change that to a pressure trigger just by dialing it, tapping it. And flow is up. When you get down to 0, it changes to pressure. We'll keep it at flow at 3. Okay. And let's go back out, accept. Okay. And so I'm going to hook this up to the quick lung breather, and you'll connect it right to here. Okay, you want to keep this arrow pointing straight up to resistance of 5, which is normal resistance. And when we check for resistance, we'll be moving it to 50, which is the pretty high resistance, or we can go to 20. Okay, so basically that's how we're going to adjust it. So make sure this arrow is pointing up to 5. Okay, let me hook up the ventilator real quick. Okay, remember on this one here, because of the O2 sensor is not working, that alarm for oxygen is going to keep going off. We just have to keep silencing that for now, okay? So anyhow, I have it hooked up to the pneumo, sorry, not the pneumo lung, but the quick lung. It's connected here at the number 5 resistor. The springs are not attached, as you can tell. No compliance issues here. So now you want to access the loops in your waveforms. Well, we have the waveforms, the basic ones here, the scalars, but we're going to go to menu. And, okay, not the menu, quick access. Okay, quick access will show us the loops, and we're going to go up to the loops. And we have a loop here. So we're looking at the top one is the volume pressure loop. Okay, and it looks a little different than the other one on the 980, but anyhow, it doesn't really matter. You got the inspiratory limb, expiratory limb. So right now what we're going to do is we're going to have to do a compliance on this, okay? And what you need to do is go to, I think, additional values, and down here on the bottom here it has inspiratory hold. Okay, the next where I went to other values, this will actually show you the plateau pressure up here. Okay, keep in mind the PIP. We're going to change compliance in a moment. So PIP is 13, 14. Plateau pressure, we're going to create an inspiratory hold, and this is you're gonna have to, when you press it, it'll open up it's not gonna do anything. You have to actually press. Let me silence. I'm gonna press and hold for about 4 or 5 seconds on inspiratory. It's holding up there, and let me let go, and it should, your plateau, there's your plateau up there. Okay, so you're going to press and hold the inspiratory hold button. That's going to manually do that. Okay, so remember what that was. You need to calculate compliance. I think it might even show it on here. Let's just kind of look. Okay, there is, let's see, it's got static compliance. Oh my God, okay, hang on, let's do that again. Inspiratory hold. Hold, and let go. Let's see. Does it spit out the compliance? Okay. So this one did not spit out the compliance. So anyhow, you're gonna have to calculate the compliance. I'm gonna change this. Silence. Okay. Okay, so we're back to the page that displays plateau pressure. If you remember, plateau pressure was 12. So do the formula for plateau pressure and come up with your compliance, okay? And then you can see that is the waveform currently right now. It's probably going to be pretty good compliance. Plus the waveform, the loop is straight up, okay? I'm going to increase compliance now. I'm going to do that by adding some springs. You're going to have to kind of do this, as the lung comes down, hook it up on the bottom plate. You might get an alarm there. I just hooked it up. Let's take a look. Okay, so the servo actually adjusts. Hang on. The servo actually adjusts the scale of the loop, but it has come down closer to the pressure line. Let's look at your compliance or the plateau pressures. Let me get a few things out of the way here. So we're going to do, now we have pips are 22. They were 14 before. You want to keep note of that. Okay, I'm back. So let's do the inspiratory hold now that we added one spring for compliance. And we want to do this at the peak inspiration. Hold it and let go. And now you can see that plateau pressure. That was 21. It was so quick. So keep note of that. Calculate what static compliance is. Okay? And we saw what the loop looks like. Okay, let's add another spring. I'm going to do the small spring here. There we go. Now, more compliance. Yeah, this already adjusted the scale. It says 40 down there now, and it's actually we're kind of high on the pressures right now. The pips are 30. Then you're going to do an inspiratory hold. Let's see if we can get this done. Hold. Let go. Compliance 28. There you go. So it just briefly showed up there. Okay. So calculate the static compliance. You can see that the waveform has significantly dropped lower to the pressure line, and the pressures are up. Okay. So now you can do that formula and see how compliance has changed. Probably has gone down. Okay. We're going to do airway resistance here in a minute. I'll be right back. Okay, I am back. I reset the compliance springs. They are not longer connected, and we're back to our waveform here, the loop, and you can see the scale is down to 20, and our pips are back to where they were at 14. And now what we're going to do is we're going to look at airway resistance using this lung, okay, the quick lung. So I'm going to first increase resistance and bring it up to 20. So I'm going to turn this over. Hang on, I have a feeling this is going to alarm. Oxygen, let's reset it. There we go, 2 minutes. Okay, so I'm going to turn it over to 20. There we go. So now we're created airway resistance. Remember what that volume pressure loop looked like? You can see how it got widening of the inspiratory and the expiratory limb. So that indicates that there is increased airway resistance by looking at the loop. Okay, let's go over to, see what happened to compliance. Okay, well, remember peak inspiratory pressures, they were 14 with no resistance and no compliance issues. And it went up a little bit, but let's look at plateau pressures. Remember that one kind of gradually went up to 12, then it went up to 20, 21 or something like that, and then up to 30, I forgot. But it started going up. So we're going to do an inspiratory hold. Let's look and see what plateau pressures. Normally with increased airway resistance, we won't see much of a change with plateau pressures. So I'm going to do an inspiratory hold. Okay, and there isn't. So right now it shows a plateau pressure of 12, which that's what it was normally. Okay, so I'm going to increase airway resistance to 50. We might alarm on this. Let's look. Boom. Now look at the loop. It's gotten super fatter. It has created high pressure, and it is alarming right now. I'm going to just change that alarm on the peak inspiratory pressure. Just take it up just for the purposes of 50. Let's see if that does it. That should be it. Good. So pips have gone up peak inspiratory pressures have gone up. Hang on. You can see the hysteresis here, the widening of the inspiratory and the expiratory limb. Of course, there's increased pressure because of the airway resistance. Let's look at plateau pressure here. I'm going to do an inspiratory hold. Let's see, hang on, right now. Boom. So I just did an inspiratory hold, and you can see, look, plateau pressure, there was 13. Just slightly went up, but it's very insignificant. So I want you to be able to do that on, you don't have to do both lung simulators, okay? But I do want you to do it on, just to be able to look at the waveform, to be able to distinguish what happens to the loop when there's an increased or decreasing lung compliance and when there's increasing airway resistance. You should be able to look at the loop and also look at the compliance. Do the calculation, do the airway resistance formula, and look how those things change, because they are independent. If there is decreasing lung compliance, remember, we're not going to see PIPs rising as much. They will rise. Okay, they will rise, but again, we're going to see compliance plateau pressures rising. Okay, it doesn't happen that way with airway resistance. Increased airway resistance, compliance doesn't change, but you'll see PIPs increasing, and then you guys should know what to do, how to troubleshoot compliance issues and airway resistance issues. Okay, there we go. That's going to be your lab this week, Thursday and Friday. All right.